Hello, everyone. Hope everyone can see my shared screen and my video now. Welcome to week 10 of statistical analysis in public policy and public management. Starting from this week and the following week, we are going to use R to conduct statistical analysis. The statistical analysis content would be the same as we learned in previous weeks. So it's about descriptive statistics, inferential statistics, linear regressions, and we may also, think of something like, as structure equation model, factor analysis, and PCA. All those things we've done in previous week can also be done in R. But in this week's class, we'll only learn some basics of R, basic operations of R, and do some, descriptive and inferential statistics in R. Okay, so before we start to use R, we will not, we'll get into this Word document. In this week, we will not have any PowerPoint slides. We just use this Word document, combining with two R files. One is called R basics, the other is called statistical analysis. So based on the document and the video show about the, any R operations in R, we'll go through those R functions. Also, those two files will also be shown in class to answer your questions, also to show you in person when you confront error messages or warnings, okay? So before, close it. So before we get into those R code, we have a question in mind, why R, right? Since we already learned how to use SPSS to do statistical analysis, why we still need to use R? Well, it is not a must, but capability of using R will really help you to build connection to practitioners, also to future research if you are going to pursue a doctor degree in the future. So even though you may not pursue a doctor degree when you go to work, you may see some colleagues from data analytics teams also using R. So your analysis can be smoothly shared with your engineering colleagues, your analyst and scientist colleagues, okay? So why we're using R? First, R is free. Okay, either you're using SPSS like we are using in this class, or you might have some experience in data which is usually commonly used in economics field, and SAS, which is commonly used in government and pharmaceutical companies. All of the rest software costs a lot of money. Okay, SPSS might be the cheapest one among the three. It's like $100-something US. I don't know about the price in Hong Kong, but in the United States, it's around $100-something every year you have to pay. Okay, and for SAS, it's even up to $1,000-something there. So R is free, costs you no money. And we are poor students, scholars, professors. By our own, we cannot afford those, the expensive softwares. So R is free, which is very good and friendly to us. Second one is the syntax in R is quite simple, comparing to other computer languages such as Python, Java, C++, or C even. You may find those computer programming languages are like foreign languages. They have lots of syntax. They have different ways to define functions, data structure, all the things there. You have to build a lot of tools from the scratch. But in R, everything is built in the backend. You do not need to build lots of those basic tools, data structure. You only focus on the analysis part, the statistical analysis part, just as you are doing in SPSS. The other thing is R is a scripting language, which means the result will be immediately shown once you execute the R statement. So you don't have to, finish all the code and click a run button. And, if something wrong, it will not give you an answer. No, it's not like that way, even though we can do R that way. But in a typical analytical process using R, we do not do it that way. It's more like an interactive way. So you write an R code, run it, it will show you a result. If it is an error message, you just revise your R code, run it again until it gives you a readable, correct answer. So it's more interactive. It's a scripting language. The third one, R is quite flexible, which means you can, record every step you were doing in your previous analysis, right? Remember last week we've done structure equation modeling in AMOS, right? We draw all those fancy pictures. But if the problem goes complicated, you may not remember what are the steps to draw all those pictures, what are the steps to set all those parameters. And there exists no Word document or log document that you can refer to replicate that result. So if you try to replicate a result, that is quite painful. SPSS also provide their own language, their own syntax to record every step. But if you want to do that, you need to learn SPSS syntax instead of R syntax. It's still a new programming language. So now that no matter what software you're using, in order to replicate the result, you have to learn some language. Just R. R is simple, okay? And this is also very flexible because in SPSS, remember you need to click some button, go to some menu, set some parameters to get your result, right? If you want to customize your operations, why I have to click that button? Can I click some different button, right? Why I have to set some parameters? What if I want more parameters? Those are not provided in SPSS. How can we do, right? You can't do too much on that. You can only work on your data. You can change the buttons in SPSS. But in R, you can customize your analysis. You can do whatever analysis you want. You can just like a Lego building block, you can build, buy those basics, bricks. You can build castles. You can build even, Star Wars, the flagship, right? So R is that flexible. It's like those bricks. And the fourth one, our community is quite active, which means you can always get the most updated algorithm in R. And if you confront any questions, you just post it on any online forum. You can probably get and respond very quickly and in time. So you can find lots of scholars who develop algorithm, who develop new methods, are also the authors of our packages. So you can directly download the packages from the author themselves and run the R code. However, in SPSS or Stata or SAS, because they are commercial software, their packages have been already embedded in their software once you buy it. It is kind of difficult or it takes time, much longer time to add new packages into your current SPSS software. So you may see we have SPSS software 28 version right now. And it's almost like 1 year you're getting 29 version, something like that. So every year they try to update the software. So probably the fast version you can get would be the next version, which will be 1 year. You have to wait 1 year to get the package uploaded. If they also agree to sell their package to SPSS, okay. But in R, always, they also just develop their packages themselves and publish on our community almost immediately. So you can download, you can, click your subscribe button on some R community forum. And when they also update their packages, you can automatically receive that notice to download this package. So it's quite good. The last one will be the cross-platform. So R is a cross-platform software. Many statistical softwares are based on some computer operating systems. Most of them can be run on Windows system. Some of them support Mac OS. Very few of them support Linux because Linux is an open source operation system. And those are commercial softwares, which means their source cannot be open, cannot be seen by others. So it violates the open source license. So they have to, and they are not willing to share their, commercial code to others. So you really can't find any, SPS Linux version, something like that. And for some software, for example, SPSS AMOS, I cannot even find a Mac version, so I have to use that on my, on the desktop in class, right? Because I don't have a Windows desktop. So, but R is different. You can run R across different platforms. That means you can, build your R code on Windows and share your R code with Mac users and Linux users. They can run the R code, without any question. Okay, it's problematic. So it's with no problem. So we can also build our code on any of the problem. We can also share our code among any problem. So it will be very nice for scholars to share our works to to also to collaborate with different scholars and friends because it's cross-functional. So that's not all the reason that why we are using R, but those are quite important reasons. So before we get into the basics of the R, we have to install R Studio, and R packages, and those instructions has already been taught in week 7. So if you haven't installed R Studio or R packages, just refer to the video in week 7 to get your R software installed, get your R Studio interface installed. And for our packages, we are going to load some package this week and next week. So we may install the packages when we are doing the analysis. Okay,